Have you ever just stopped and really thought about numbers? I mean, not what they do, but what they actually are. Are they some fundamental truth of the universe that we just discovered, like finding a new continent? Or are they just a really clever tool, a language we invented to make sense of the world around us? Let's get into it, because today we are diving deep into one of the biggest questions in all of mathematics. And to help us on this journey, we're going to lean on this really famous, really provocative statement from the 19th century mathematician Leopold Kronecker. He just draws a sharp line in the sand. He says some numbers are divine, they're God-given, and the rest, well, the rest are on us. This quote, this is going to be our central mystery.
I mean, seriously, what does it mean for a number to be from God and another to be from man? That is a huge claim. To even begin to understand it, we've got to unpack both sides of that statement. We're going to follow this story through history and philosophy, from the simplest tally marks all the way to the mind-bending idea of infinity.
All right, first things first, let's talk about Kronecker's God-given numbers. He's talking about the natural integers, the ones we use to count stuff, 1, 2, 3, 4, and so on. In his mind, we didn't invent these. They were just there, like they were woven into the very fabric of reality itself.
And you can kind of see why you think that. The act of counting feels almost primal, doesn't it? The earliest math we've ever found isn't some complex equation, it's just simple tally marks scratched onto a bone. It's this super intuitive, one-to-one thing with the world. One mark for one bison. It really does feel less like a clever invention and more like just opening your eyes and noticing something that was there all along.
What's so cool is that much, much later, mathematicians took that raw intuition and put it on a rock-solid foundation. In the late 1800s, a guy named Giuseppe Peano laid out a few simple rules, axioms, that perfectly captured how these natural numbers work. It was like saying, okay, we all instinctively get how counting works. Let's just write down the official rules of the game so we're all on the same page.
Okay, so we've got our divine integers, our counting numbers. But what about the other half of Kronecker's quote? Everything else is the work of man. See, the thing is, you can't describe the whole world with just 1, 2, and 3. What happens when you owe someone money, or you need to split a loaf of bread? Simple counting numbers just don't cut it. So what do? We had to get creative. We had to invent new numbers.
And let me tell you, this did not happen overnight. It was a long, messy, and totally fascinating process. Fractions, or rational numbers, they show up way back in ancient Sumer and Egypt because people needed to handle division and measurement. But negative numbers, get this, it took centuries for people to finally accept them as real numbers. And then came complex numbers, which popped up to solve some really tricky algebra. Each new number was like a new tool in the toolbox, built right on top of the old ones.
And you can see exactly how it all builds up, layer by layer. It's beautiful, really. You start with the natural numbers. Then you need to handle debt or opposites, so you invent negatives and zero, and boom, you've got the integers. Then you need to slice things up, so you invent fractions, and now you have the rational numbers. Each new level of this number universe was a human invention, a creative solution to a brand new problem.
And the history here is just full of awesome little surprises. For example, most of us learn in school that the imaginary number I was invented to solve the equation x squared equals -1, right? Well, that's not actually the real story. It showed up because mathematicians like Cardano and Bombelli were trying to solve cubic equations, ones with an x cubed in them, and they found that to get to the real concrete answers, they sometimes had to take a detour through these bizarre imaginary numbers. It was like a ghost in the mathematical machine that they just couldn't ignore.
Now we get to the final boss, the biggest challenge of them all, the continuum. That's the set of all real numbers. This includes all the integers, all the fractions, and all those other weird numbers in between, like pi or the square root of 2. Trying to pin down the idea of a perfectly smooth, unbroken line of numbers, well, that turned out to be a monumental task.
Just think about it for a second. Between any two numbers you can possibly name, let's say 0 and 1, there's an infinite number of other numbers. And between any two of those numbers, there's another infinity. How on earth do you define that with logic? How do you tame that completely wild, infinite density? For centuries, mathematicians just kind of relied on intuition, They just pictured a line. But to build real, rigorous math, a gut feeling just wasn't going to be good enough.
Then, in the 19th century, a handful of brilliant minds finally cracked the code. A guy named Richard Dedekind came up with this genius idea called cuts that let him define every single point on the number line using only the rational numbers they already understood. At the same time, thinkers like Weierstrass and Cantor were creating brand new tools, like set theory, just to get a handle on the concept of infinity itself. This took staggering creativity, and it really reinforces the idea that this whole part of the number story was a purely human invention.
And this all brings us right back to our guy Kronecker and his whole philosophy. He looked at all this work on infinity and the continuum and thought it was just dangerous, fuzzy thinking. His big project was something called the arithmetization of analysis. He literally wanted to tear down all of complex math like calculus and rebuild it from scratch using only his God-given whole numbers and a finite number of steps. He hated relying on vague, intuitive ideas about lines and points.
So, who was right? Did we discover this perfectly smooth, infinite line of numbers that was already out there? Or did we painstakingly invent it, using integers as our only legitimate building blocks? Well, the debate didn't stop in the 19th century. In fact, things were about to get a whole lot weirder.
And here's the bombshell. In 1931, a logician named Kurt Gödel completely turned the world of math upside down. He proved that in any logical system that's powerful enough to do basic arithmetic, there will always be statements that are true, but that you can never, ever prove using that system's own rules. It was a shockwave. The dream of a perfect, complete, and totally certain system of mathematics was shattered.
After Gödel, mathematicians basically had to pick up the pieces and rebuild. They started taking a much more pragmatic approach. A system called Zermelo-Fraenkel set theory, or ZFC, sort of became the standard operating system for most of modern math. But now, everybody had to admit that it had limits, and the debate shifted. Is mathematics just a really consistent language we invented, a formal game of symbols and rules? Or is it still describing some deep objective reality, even if it's a reality we can never fully capture or prove?
Which brings us right back to where we started. Kronecker saw this clear, bright line between the divine numbers and the man-made ones. But modern math shows us the picture is way, way more complicated than that. Maybe the integers really are a discovery, an observation about how the world is structured. And maybe everything else we've built on top of them is this incredible, powerful story that we've invented to make sense of it all. What do you think? The beautiful part is, the story is far from over.